In this video, we want to determine all of the asymptotes for the function f of x is equal to 4x squared plus 8x minus 9 divided by 2x plus 1. So first, it's helpful to remember that this is a rational function. It comes from the rational function family, and that is because it's in the form of a polynomial divided by another polynomial. So these functions are characterized by having some asymptotes. So you always want to first begin by simplifying the function if possible before you determine the asymptotes, which means we want to take this numerator here, and if it possibly factors, we do want to factor it to see if we could simplify the function at all. So if we were going to factor that trinomial in the numerator, we could be doing guess and check. So I could certainly sit and try all the possible options here, such as 2x times 2x will give me 4x squared, and then I need two numbers that would multiply to give me -9. For example, if I tried -3 times +3 as an example, then you would check the outside. 2x times 3 is 6x. The inside would be -6x, and these clearly do not add up to give us 8x. So that would be a trial and error example where then I would go back and I would change these values. Maybe I would try, for example, 4x times 1x and see if that would work. Or the alternative to trial and error with factoring, remember, is the AC method, where you would multiply a times c. So in this case, 4 times -9 is -36. And we're looking for two numbers that would multiply together to give us the -36, but we want them to add together to give us +8. So for example, we know 4 times -9 is -36, but that will not add to +8. So that's a no. You could try -4 times +9, but that will not add to +8 either. Other pairs of numbers that multiply to -36, you might try 12 times -3, but that will not add to +8, and neither will -12 times +3, and so on. You would go through that process, and you'd realize that there is not going to be a pair of numbers that multiplies to -36 but adds to 8. So that tells us that the numerator is not factorable. That means we cannot simplify this function at all. And the reason why we wanted to check is because if you could simplify it, then there would be a hole in this function. But since we cannot simplify it, we know for a fact that this function does not have any holes. So, long explanation to get to that point, but that is really important, especially if you're moving on to a calculus class later on. So let's go ahead and start with vertical asymptotes. Now that we know we cannot simplify this function, the vertical asymptote will be found by setting that denominator equal to 0 and finding what value would cause the denominator to equal 0. So in this case, x cannot equal -1/2. That would be a domain restriction. Therefore, x equals -1/2 is our vertical asymptote for this particular graph. So we set the denominator equal to 0. Then we move on to horizontal asymptotes, and we find those by analyzing the degree of the numerator versus the denominator. In this case, the degree of the numerator is 2, and the degree of the denominator is 1. So the numerator degree is bigger than the denominator degree. And when that happens, we do not have any horizontal asymptotes. So I'll write none. When the numerator degree is larger than the denominator's degree, we are not going to have a horizontal asymptote. And then we'll move on to a slant asymptote, which is often sometimes referred to as an oblique asymptote. Those are interchangeable. Slant asymptotes will occur when the degree of the numerator is exactly 1 bigger than the degree of the denominator. And we do have that case here. The top degree is 1 greater than the bottom. So to find the slant asymptote, we actually need to do our division. So we need to divide 2x plus 1 into the numerator, which was the 4x squared plus 8x minus 9. Now, your divisor, in this case, our divisor is 2x plus 1. When your divisor is linear, I often suggest synthetic division. However, because we have this coefficient, I would actually recommend that you do long division because synthetic division can get a little bit quirky when we're determining the slant asymptote when you have a coefficient like this one. So for example, if the divisor was just x plus 1 and we were doing our division like so, then I would recommend you go ahead and do synthetic division. But because we have a coefficient, I'm going to say we should go ahead and do long division. So quick review of long division. We first divide. So we have the first term, 2x. We're dividing it into 4x squared. I'm going to put my side work over here. 2x divided into 4x squared. That would simplify to be 2x. And I'm going to line everything up. So I'm going to put the 2x here above the 8x. So it's in the x column. So we first divide, and then we multiply. So we're multiplying 2x times 2x, which is 4x squared. 2x times positive 1 is positive 2x. So we divide, then we multiply. Now we're going to subtract. And we always have to be careful on the subtraction step because we're subtracting this entire quantity. It has two terms. So 4x squared minus 4x squared is 0. And then we technically have 8x minus a positive 2x, and that will leave us with 6x. And then we bring down the next term. So some people remember this as a four-step process: divide, multiply, subtract, bring down. And the process repeats. We are going to take the first term, the 2x, and divide it into the first term here, which is 6x. So 2x divides into 6x, resulting in positive 3. I'm going to put the positive 3 on top of this negative 9, so it's in alignment. Then we multiply. 3 times 2x is 6x. 3 times 1 is positive 3. Now we subtract, being very careful to subtract. Some people, when they do the subtraction step, will do this. They will go ahead and change it to adding the opposite and then put the little negative signs, the opposites of both of those terms. If you've been taught that, that is equally good. So this would be 6x plus negative 6x, which is 0. And then negative 9 plus negative 3 will leave us with a negative 12. And that's our remainder. When we're doing long division, however, we get to ignore the remainder. We really don't care about its value, and we're just going to focus on our answer up here, the quotient, which is 2x plus 3. So that means that the line y equals 2x plus 3 will be our slant asymptote for this particular function.